Below you see the table. We want to do 6 follow-up workshops, 1 on the e-dolly and the AMPT, then the front-end design, intelligent access policies, the Procter & Gamble use cases, next steps, the modeling of freight, and the cost-benefit tool supporting seamless integration of AEROFLEX innovations. At the end of this session, we will give you the opportunity to identify which workshop you would be willing to join. So maybe you can make a note during the session that you indicate for yourself, this is something interesting and I want to give this a follow-up. The agenda, as said, has 3 blocks. The opening session, which will be done by Fernando, Lisa, and myself, including Per and Giuseppe, who go in depth on some project highlights. The second session are 4 topics: the Procter & Gamble use case, next steps, what to do with smart loader units and tools, the modeling of freight 240, e-dolly and the next steps, intelligent access policies. Finally, we want to give you an outlook. What are the next steps and what are our initiatives after the project AEROFLEX is ended? By this, I think I want to hand over to Fernando Lisa, who will guide us shortly through the Alice platform. Fernando, please.
Yeah, very quick, because today AEROFLEX is the protagonist. Just as an introduction, we are very happy to host this webinar today of AEROFLEX that is reaching the end of the project, and in Alice we have go hand in hand with the project since the very beginning. I still remember the first meeting in Munich when we could still meet face to face, and it was so nice. But okay, let's go to the next. To the next one. Alice is an association based in Brussels. We have 140 members, and later on I'll talk about this. And what we do is to look into how logistics should and could look like in future, and based on that we provide recommendations. We create roadmaps, we develop research and innovation agendas, and then with this we create the recommendations for the European Commission, member states, and also the industry on the investments in research and innovation. What we also do is to, as we are doing today, following up the projects that are funded under these programs, and look how these projects are contributing to the implementation of our roadmaps, and really also share that knowledge in our network and in the full logistics community. Last but not least, as we are a very rich organization in terms of skills, capabilities, and different type of organizations, we create a framework for collaboration and creating partnerships for projects. And then in Alice, we have 5 areas of intervention. It's the first one, it's on sustainable logistics supply chains, and there is where we focus really on energy efficiency of the vehicles and also the assets, but also on how we can use low emission energy sources. Then we have corridors, hubs, and synchromodality, in which we look into how we can better use the different transport modes. Then systems and technologies for interconnected logistics, in which is everything dealing with digitalization and how we can use digitalization for better and more efficient logistics. And the fourth one is coordination and collaboration. So how we can really enable that the flows of the different cargo owners, shippers can be combined, and then the assets be fully utilized. And the fifth one is a focus on urban logistics, where we apply all these topics in the context of urban. Our long-term vision is to really reach the zero emissions logistics by 2050. And the way forward, if we go to the next slide, is really how we can make this affordable. Because as it is of today, the transition towards the low and zero emission assets is still not in the exact profile in terms of cost and capability on return on investment. And there is where we need to, thanks to more efficient logistics, try to get closer to the way in which we can transition our assets and vehicles, so then we can afford this in a suitable way. And today we have indeed the context, in this context, the project AEROFLEX that is really contributing to this end. And of course, what these three areas in which we go into more efficient logistics is what we call, or it's under the umbrella of the physical internet. We released 2 roadmaps in 2019 on zero emissions and last year on physical internet, in which you could find more information on what we are trying to achieve. If we go to the next slide, then this is who we are, and you see we have representatives of the various stakeholders in logistics and from various angles. So this creates a very rich overview of the problems and issues, but also on the solutions. If we go to the next slide, and then just to conclude, and part of our program of knowledge management, we have a liaison with various projects at national but also European level that are working in areas that are relevant for logistics and for the implementation of our roadmaps as AEROFLEX. And then we create this framework for understanding which is the contribution of these projects and how we can take over for getting close to the implementation of this and really achieving the objectives, or to understand which are the additional issues that we need to face in upcoming programs. So if we go to the next slide, at the end with all this, our ambition is to really create a network of people and companies that are able to connect and make progress in terms of efficiency and sustainability of logistics. We are also creating a think tank, so then we see also how we need to move forward, and also we gather and share knowledge in our network. Next slide, please. And just this is all on our side. Just thank you, the whole AEROFLEX team and all the participants of this webinar for joining today. And here you can see in this slide 3 of our models in ALICE that define how we are approaching this very challenging theme of sustainable logistics and freight. So the floor is yours.
Please mute yourself.
I take care, Ben.
Okay, good. Thank you very much, Fernando. I will now start to give a short project overview, what we have done in the past years. As Fernando said, October 2017, we have started our project. The project was initiated already end of 2014, early 2015. And here you see all our partners. So we are really having a strong team of OEMs, trailer manufacturers, suppliers, research centers, university, testing center, engineering centers. So we really can speak that we have a broad team, and we even have integrated in our project team the combined transport railroad, as you can see by the AERR. Where are we focusing on in the project? It is about technologies and innovations. And we have said we want to focus on the complete vehicle. So it is not only the truck or the rigid, no, it is the complete vehicle, including the trailer, the semi-trailer, and all the equipment. For that, we have developed and we have focused on powertrain energy management, so that we really can have a management system which is coping with a distributed powertrain. Later this session, Julius will explain in detail what this is about. In principle, it is the powertrain distributed over all the units of the complete vehicle, and it's managed by one control unit. The second innovation in this is the smart steerable dolly. The idea was to split the vehicle, and a dolly can move then the vehicle, the trailer, to the loading or unloading bay. And secondly, if the dolly is smart, it can be incorporated in the drivetrain. The third innovation is about aerodynamic devices. And we are talking about active aerodynamic devices for the complete vehicle. So including the trailer, including the bodies. Fourth, we are looking at smart loading units and tools for more efficient loading space utilization and multimodal transport, because we believe that optimization of the efficiency, how to use the loading space in a loading unit, and how to improve multimodal transport contribute to our targets we have to achieve. Finally, the front-end design of the vehicle. We have looked for an architecture incorporating safety systems to improve the survivability for the driver, the road user, and vulnerable road users in case of an accident. So the idea was, how can we improve the design and how can we incorporate features to reduce collisions, fatalities, and injuries. What are the challenges we have addressed within the project AEROFLEX? We know that the transport is responsible for about 25% of the total CO2 emissions in Europe. And we know that the growth of transport is about 20% in 2030. We also know that we have the Green Deal, and the Green Deal is targeting a 90% reduction of CO2 by 2050. If we look to the cost of transport, and if you look to the total cost of ownership of a typical long-haul fleet, then we see that cost of transport, we have to deal with high costs on the pre and post related processes, and we have to deal with high costs on the climate impact and the accident impact. Regarding the total cost of ownership for our fleet, we have to look at the driver wages and the fuel and the utilization, which is at lower level than 50%. So it is obvious that in the project AEROFLEX, we are looking at how can we reduce CO2 emissions and the impact on the climate? How can we reduce road accidents, injuries, and fatalities? How can we improve the total cost of ownership and reduce the vehicle kilometers per ton freight? And what can we do about the cost on the pre and post related processes? To work on that, we have designed a project structure, which is in the middle, the boundaries and the constraints. So in what type of world are we living? What technologies and innovations to focus on, how to demonstrate them and to see what is the impact and come up with recommendations for new standards. On the left, you see the goals that we are looking to: technologies, concepts, architectures, and standards. And these standards make it already necessary that if we want to match vehicle concepts and the infrastructure as is today, we need to define standards for the vehicles, and we need to find standards for access to the infrastructure. We have a vast demonstration program. We have vehicles we use for the reference test, the advanced test, and currently we are running with our demonstrators. The vehicle is the powertrain, the vehicle is the aerodynamic features, and we will do a test with EMS2 vehicles. Finally, we will do the evaluation, impact assessment, and cost benefit based on real world use cases. And we are creating a cost benefit tool to make available for operators to decipher themselves in the future, how can I use the innovations in my fleet? Finally, we are having set up a sounding board where we constantly mirror our work we are doing in the project. We are looking at recommendations, how to revise standards and the legislative framework. And we are looking at the legislative framework for the policymakers, how we can bring the innovations to the road. And now I would like to hand over to Per and then to Giuseppe. Per.
Thank you. Good afternoon, everybody. I will present an update on the aerodynamic activities within the AEROFLEX project. So next slide, please. So what we have decided to do within the project is to use a combination of passive and active aerodynamic devices to reach the aerodynamic targets that we have within the project. So with passive, it means devices that has a permanent shape and sits permanent position, and with active, it could either be that we adapt the position of a feature, or that we activate it, or that we change the shape of a device. We have used a lot of different tools for the development work within the project, and the cornerstone and the basis is the computational fluid dynamics, or CFD simulations, that have been used to a large extent for developing these aerodynamic devices. And then to validate or verify the simulations, we have designed and built a 1-to-3 scale model, which have been tested in 2 different wind tunnel test campaigns in the FCA wind tunnel in Turin. And then as a final step, we have built a demonstrator, a full-scale demonstrator, and with this we will do the final verification of the devices and innovations that we have achieved within the project. If we look at the progress since the last webinar in September, we have handed over the demonstrator to IDEADA, and the testing has started late 2020. We have submitted the deliverable 3.5, which describes in detail the build-up of the demonstrator, and we have now just recently finalized the detailed simulations on the final demonstrator geometry. And also we have looked at and quantified the performance you can gain when applying the aerodynamic devices on an EMS2 configuration. And at the moment we are planning on which publications to do and which conferences where we would like to present the material and results from AEROFLEX. So next slide, please. On the demonstrator, we have implemented 14 aerodynamic devices that were selected to be implemented. You can find them listed on this slide. I will highlight some of them. The key thing then is, or the starting point is the box, the swap body box and the trailer box that have adaptable or movable roof. So if we don't need the full internal volume, then we can reduce the height of the loading area, and by that we can achieve a drag reduction. And for this to be really beneficial, we have added a device to the truck, which is an active air deflector that adjusts the position to the height of the swap body roof. The complete vehicle is also equipped with a lot of side skirts. We have side skirts with extensions on the truck. We have a side skirt and a fairing on the dolly, and then the trailer has a large side skirt as well, and it has been complemented with an active side skirt extension. So you can gain even larger performance when you're driving on roads that permits this larger surface area on the side skirt. And then another thing is the gap reducer that reduces the gap between the truck and the trailer, and thereby improving the aerodynamics by preventing air from flowing between the 2 units. And then at the end, of course, we use a boat tail to improve the aerodynamic performance of the combination. If we move on to the results, when we look at the drag reduction that we have achieved, we have evaluated that using CFD simulations, and for a tractor semi-trailer combination, we have obtained a drag reduction of more than 40% in CD times A when comparing with our reference vehicle. The corresponding numbers for the EMS combination, a truck, dolly, and semi-trailer, that is about 40% drag reduction. And then if we look at the demonstrator, and which is a detailed geometry with some of the features that we have developed, then we get a drag reduction of about or nearly 30%. And of course, these large drag reductions, they will translate into significant energy consumption and CO2 emission reductions. And the key thing then with them is, since we have also used active features, we can ensure that we get the optimum performance independent of the loading surroundings or the loading characteristics, and without or with minimum or no impact on the cargo handling as well. And with that, I would like to hand over to Giuseppe for the next part.
Yes, thank you, Per. Okay, hello. Well, happy to speak in front of you. Today I would like to talk about the front-end design for more safety. And yeah, the elongated front-end offers the possibility to extend the safety capability of the next generation truck. So basing on this extra space available, we started to some study in order to understand which protective structure in the front and which ADAS system could bring benefits in terms of safety. In particular, for the passive safety structures, we added a protective structure in the front, in the lower part of the chassis, to address one of the most common accident scenario, that is the rear end collision that involves often long haulage trucks. And yeah, we have proven that this kind of structures in the front can bring benefits, can absorb energy during an impact, and can reduce the intrusions in the back of the car. We also tried to add some protective structure in the front in order to mitigate the collision of the truck itself. But simulations and the activity in general showed that the amount of energy is too big to be absorbed with the protective structure, despite the front end elongation. So for this last case, in order to ensure the proper protection to the truck occupants in general, to mitigate and to reduce the number of accidents, we studied also the possibility that we introduced some ADAS system in our study, and I will explain later. I will provide some detail later about that. Yeah, benefits in general will be that ADAS combined with the structure I have explained before will for sure reduce the serious injuries and the fatalities. Next, please. We also, the extra space in the front can also bring some benefit for pedestrians and VRUs in general. The distance between the stiffer parts of the front end is increasing with the elongation of the front end. So for this reason, it's possible also in this case add some feature that can for sure help the protection of the pedestrians and VRUs in general. We did a study with human body modeling to have a dip analysis on the pedestrians, and then we set up some simplified tests basing on head impactors and pelvis impactors in order to optimize and to study the features in order to reduce the aggressivity of the front end towards the pedestrians. Yeah, we have seen that some modification in the front end, in the windshield area, some additional reinforcement in the glued area in general, and the reduction of the headlamp box can bring some benefit and can reduce the injuries of the pedestrians. So benefits, yeah, extended front end can be equipped with the above features and reduce in this way serious injuries and fatalities. And yeah, let's very quickly, yeah, this is a slide that wants just to highlight that we also did a deep study on several ADAS systems like automatic emergency braking, sidecar warning, and line support system. We did some simulation basing on the accidentology scenarios, and we proven with the simulation that also this ADAS system can bring benefits in avoid accident or reduce the effect of the collision. For more details, I suggest to have a look on the TRA paper that describes what I explained before. This paper is called An Analysis of European Crash Data and Scenario Specification for Heavy Truck Safety System Development. Yeah, that's all from my side.
Thank you very much, Giuseppe. Thank you, Per. Fernando, if you could take over for the Slido question, then I can guide the people through this question. As said, we want to have your opinion on specific points, also to to see what we have to do to sharpen argumentation and to go more in depth also in the follow-up sessions. So the Slido question we have now is, what criteria are for you most important if you look at those features to improve the aerodynamic? So is it the weight penalty? Is it the easiness of handling? Is it the active setting instead of manual setting? Is it a clear cost benefit or other? So you are kindly invited to use the Slido and to put forward your answer. And you may have used the checkbox that you can add some recommendations, suggestions, whatever. So if everybody wants to use now the Slido, then we keep it open for about 30 seconds and then make your opinion aware that we can have some information out of that. And I see that on the screen, clear cost benefit, weight penalty, easiness of handling is suddenly coming up. Weight penalty is important, we see. Okay, we have 24 answers, 25 answers, 26. Okay. Then thank you very much for this feedback. Fernando, I propose we continue.
Sure, yes.
We can later at the meeting see what are all answers, and then we can maybe derive a conclusion out of that.
Sure, you can just share your screen now. There we are.
Okay, yes.
I will keep it open, the slide
yes,
for people willing to vote yet.
Yeah, we go now to the second part of this session. That is about smart loading units and tool, and I kindly invite Ton Bertens and Hilal van der Holst to present this part. So Ton, you will kick off, and then Hilal, you take it over. Thank you.
Thank you, Ben. Hello all. My name is Ton Bertens. I'm manager of research and development at Vanek Trailers. We contribute in the AEROFLEX project in different work packages. Hilal and I are now going to tell you about the smart loading units from work package 4. The smart loading units developed in this project. It all began with the proto of the volume optimized trailer we developed in the Transformers project. A trailer with a huge inner length, a flexible floor and a movable roof to reduce the drag when the trailer is not filled up to the roof. But we made it much smarter in this project. What we also wanted to demonstrate is that this trailer, though all these integrated innovations, still is a flexible unit. So it is smart to go into other modes. The trailer will then, with all these new aerodynamic features that Per just mentioned, will be made craneable and then will be tested in the CFL use case in the end of the project. So the trailer can still go into other modes. The prototype of this trailer was first tested in the Transformers project. These tests proved the technical possibilities of the movable roof and the flexible floor, but also showed how difficult it is to introduce this new system into the market. How can a planner decide from the mix of pallets he needs to get from A to B what the optimal configuration is to fill the new trailer? How to divide them over the different floors, and how we can prevent to overload the axles with the double stack system. Which pallets can be double stacked and which not. How we prevent the roof to hit into the cargo when coming down. For this, the puzzle software was developed. But what also was missing, a tool to measure the used volume of the trailer. We are always talking about the weight of the cargo and never about the volume. It just isn't known. To be able to evaluate the efficiency of this flexible double floor, we defined the new cargo cam. It not only calculates the exact volume of the cargo, but also the distance from the top of the cargo to the roof. Hilal will tell you more about it in her presentations. Next slide, please. In the Procter & Gamble use case, as we call it, we are going to test the efficiency of the flexible floor. The goal was to set an efficiency improvement of 4 to 6% with the flexible floor system. With the flexible floor, you can create an extra shelf for 4 pallets to put on top of it, and 4 pallets to put under it. The forklift can set the floor at a very flexible height and put pallets on top of or under it. If you don't use the flex floor, it's not in the way. The trailer floor is then still a standard flat floor. In cooperation with Procter & Gamble, we defined the test lane, a shuttle driving between 2 warehouses. It was planned to let the puzzle software plan the optimal filling of the trailer, going from A to C, and the optimal load for driving back from C to E. The cargo cam would register all timing, how much extra time we would need to load the trailer, and measure the efficiency improvement. The first tests without a flexible floor were made to define the baseline. Then using the flex floor with the planning done with help from the puzzle software. But due to the COVID lockdowns, we are still not able to do these tests. We even discussed to create a bubble, as you see in the picture on the left down, halfway the warehouse. And in this bubble, we could unload the trailer with standard cargo, calculate with the puzzle software an optimal configuration, and measure then the time and the gained empty pallets places as an efficient improvement. But these plans are still blocked by COVID rules. What we now are planning is to do a test in the summer after the project with Procter & Gamble. The trailer will go there in 3 to 4 months, and we'll do a big testing after this project. Next slide, please. How does puzzle software help us in reaching our goals from the 4 to 6% energy savings? Puzzle software was originally developed to optimize the filling of a pallet with cases, but now it's extended with a module to optimally fill a trailer with pallets, which has a double stock option. In the puzzle software, the database of a mix of pallets with dimensions and weights can be imported by an Excel file. From this set, Puzzle will make some proposals to optimally fill the trailer. In this example, you see the content of a shipment of Procter & Gamble, which was already optimized. They have pallets defined as double stackable. If you can put pallets on the top of each other, they are double stackable. They have optimized their shipments and come to a filling of 58% for the volume of a trailer. If we let the puzzle optimize the filling of the trailer and use the flexible floor, we can see how many empty pallets we can create in the picture on the top left. This picture has been made by the puzzle software. We create empty places in front, and we fill those empty places with pallets again. And then we can see the filling has grown up to 77%, so a gain of 40% to the original filling of the trailer. So this is a big efficiency improvement by the software. Now the next slide for Hilal.
Good afternoon, everybody. I am Hilal van der Hulst from the DEF Group. Now I'm going to present you the cargo cam technology. Our main objective is load optimization, improvements, enhance the vehicle aerodynamics and efficiency improvement using 3D sensor technology in combination with the computer vision-based algorithms and software. We identify the loading space and hence have the volume detection inside the trailer based on the sensor solutions. And we already have our proof of concept and prototype for the implementation, installation, and test in the AEROFLEX trailer. So we have already grid-based volume detection to identify the free and occupied space inside the trailer. If we have a look at images on the upper right corner of this slide, in the first one, we see the image taken by the sensor that is installed on the door on the upper roof side of the trailer. This is a grayscale image. In the middle, you see the image of the loading taken from the front sensor on the trailer. And in the third image, you see the 3D point data, an illustration of the actual loading inside the trailer and using the cloud data provisioning. So overall, sensor solution is composed of the 2 sensors, 3D sensors inside the trailer and the algorithms. And in the video down, you see the forklift going inside the trailer and unloading the cargo inside. So the image on the upper left corner is a grayscale image coming from the 3D point cloud data, and the image on the lower right is the shows the grid-based volume detection. Here, the green corresponds to the actual volume. This is detected, so seen by the sensor inside, and then the red is the assumption, and the blue corresponds to historic data. Also this using the help of the telematics units and cloud backend, there is also a possibility to have the remote access to the 3D data, which will be explained in the next slides. And if you look at the outlook of the CargoCam technology, in the Q3 of 2021, we are going to perform the infield test at Procter & Gamble. And of course, at the final event, we are going to demonstrate our technology further. So here you can see the setup of the CargoCam technology. So first we have the Vanek Transformers trailer with an adjustable roof. And our hardware is composed of 3D sensors in combination with the telematics unit that is installed in front of the trailer, and also supplementary equipment. So what is done is, by the help of 3D sensors inside the trailer on the upper ends, you detect space, available space or occupied space, and then 3D point cloud data by you is analyzed using the algorithms and detects the actual volume inside the trailer. And then telematic units receives this detected results and stores it. And by the help of the ZDEV cloud, this data could, it's possible to have remote access to this data. And also, it's also possible to do further offline processing, analysis, and visualizations in the later stages.
Thank you very much, Tom.
Thank you very much.
Thank you. Yeah, it's now time for some questions, for discussion, because we realized that the CargoCam is a new development. The last webinar, we announced it, and I think we made a huge progress. So maybe from the participants, there are some questions. I have some questions prepared, which we could highlight. Maybe Hilal, you can kick off to maybe elaborate a little bit on the first topic. How do we see that the CargoCam could be an enabler for automated loading and unloading? So Ton and Hilal, maybe you could both elaborate a little bit on that, and then I hope that from the participants there will be some questions.
Well, if I would start, I would emphasize a feature implementation, like integration of the current cargo cam technology that detects the volume inside the trailer in combination with adjustable roof, like aerodynamic systems, so that based on the detected volume, the roof could be adjusted to the optimized height. That is something I would like to address. And also we have additional innovations that we are working on, but due to confidentiality, I am not able to share it at the moment. But my main intake would be the combining this technology with the aerodynamic systems.
Okay, thank you, Hilal. Tom, do you see any combination of puzzle software and cargo cam that we can have their benefit from?
Yeah, yes, of course. What Hilal just said, the puzzle software can give a predicted height of the cargo as it is, and cargo can check it. And then you also have a check if the trailer is loaded according to the puzzle software calculations. And if you don't do that, you can still overload axles and things like that. So in here you have a kind of double check that the cargo is loaded according to pre-calculations.
Okay, thank you very much, Tom. To continue, the market for double stack trailers.
Yeah.
Have you yourself already some requests for this, or how is the situation at this moment?
Yeah, we do a lot of double stack trailers. So we have the twin deck trailers, which are coming up more and more into the market. But this double stack system, this flexible system, we just built a prototype and then the trailer went to this project. So it's stuck in the project and we can't go further with it. But as I said before, we will do after this project a 3 months testing at Procter & Gamble. So they are now really serious about investigating the double stack options.
So you would certainly like to hear also from the audience some feedback about the double stack trailer if there is interest. So all the people who are now listening are kindly invited to use the chat or come back to us by mail to give your feedback on this idea of double stack trailer. Tom, to close this session, the cost benefit price model, how do you look at that, and how can you have help from the audience who are listening to us?
Yeah, for us it's important because these smart trailers always cost a lot of money extra. But what we see in the double stack trailers, that the investment can give you a big reduce in your total cost of ownership if you have the correct business for it. So that's why I like to hear from people from how can their business match with our goals of double stack, and how must we design the double stack trailer that we can have influence on the reduction of the total cost of ownership.
Okay, thank you, Tom. Anyone who wants to react at this moment before we go on? I allow 1-2 minutes to get some feedback out of the people. I see here Bart van Rijn, double stack. Sorry?
Ben, it's Mark Bier from IRU. I would like to say something, please.
Yes, go ahead, Mark.
Well, first of all, congratulations to the entire consortium for this fantastic project. This is really bringing some further innovation into the limelight, and that is exactly what we need. Now, when we're looking at double stacking and cost of ownership is, of course, a very important aspect. But looking at it from a wider perspective and also bringing the political dimension into the picture, double stacking is also a possibility to optimize efficiency and to carry more with less. And this is, of course, also very positive for fuel consumption and for emissions, and can contribute to us implementing the Green Deal.
Definitely. Thank you very much, Mark, for your comments.
Yeah, we often see in our calculations that the transport that normally will be done with 4 trailers can now be done with 3 trailers.
Yeah.
And then you have an enormous savings in CO2 emissions.
Indeed, Tom, that is exactly what we need.
Okay. Any other remark before we continue? I saw a lot of remarks in the chat box, so we will note them all. And yeah, you are kindly invited also to come back to us via mail. Thank you very much so far for this block. Hilal and Tom, I think that was a nice discussion. I would like to switch to the next part, the modeling of freight 2040, implications of high capacity transport. Andreas Liske and Christoph Jesberg. This is a known picture from the previous Alice webinar, where we have said we want to focus on the right infrastructure and the right cargo, because it is too easy to say you have to do everything by road or rail or water. We are living in a complex logistics world, and I think Andreas can lead us through some modeling DLR is working on to get a good idea of, okay, how could it work in the future? Andreas.
Yeah, thank you, Ben. I want to introduce to you something about our methodology, how we try to trigger out what is market requirements, what could be at the end of the day the impact to the European transport market. And here on the right hand side you see in the green color the things we have done to address the requirements. We have made online survey, interviews, we have had a workshop, we have literature analysis about status and trends. We analyze Eurostat road microdata, and we also have checked the EU forecast projections for freight volumes. That is part of our own modulation, so we are in line with the European forecast. Then we have one important task that is addressing trends in freight transport and also in physical internet. And one of our tasks is to bring or to see how could the AEROFLEX development could be aligned with trends in freight and transport, and one of these trends is also the physical internet. This is work in progress we are doing, and now for the next few minutes I want to give emphasis to this blue colored points this is the modeling we are doing now. It's also work in progress, but I want to introduce to you with our approach and also with some first thoughts and results we have gained. And I hope I can get some feedback to you to improve it in the next step. You see here we are working now with 5 scenarios, and these scenarios are projections to 2040. And so we want to show how the impact of this high capacity transport, and we are talking about EMS1 and EMS2 in detail. So we want to see what are the differences. And scenario 1 is only EMS1 operating. Scenario 2 two vehicle concepts, EMS1 and EMS2, are operating, 2 are allowed. And in the scenario 3 and 4, we add some additional constraints, I would say, so that could be see how regulated access policy could influence the EMS1 and EMS2. Next slide, please. Yes, this was also coming from our first work we have done. This was our approach to identify the market for high capacity transport. You see this the figure that also have shown by Ben yet, where we have seen that palletized goods and other cargo not elsewhere pronounced are the main interest for growing and the main interest for long road haulage. As you see the yellow and the blue, that are the most interesting areas for EMS1 and EMS2 vehicles. And what we want to give emphasis is, or what we want to point out, is that EMS1 and EMS2 should address growing cargo groups. And they should address long road haulage with the highest ton kilometers. So only in this way we think that we will reach the most effects of this innovation. And we have also things to consider, and this is the third bullet point on the left-hand side. That is, we have to find a solution so to limit the reverse modal shift from rail and inland waterway to road transport. And this probably you know, in the past we have some different studies about this opportunity to have a reverse modal shift. And so one of our tasks in our work package is to figure out how we can reduce or we can manage this. And last but not least, it is clear, the last bullet point, we want to contribute at the end to a EU CO2 emission reduction for all over all modes. We have to consider all modes, and in this approach, not only the road. So next. Yeah, now I come to first insight of our modeling approach. First, you see here on the right-hand side our reference scenario and our baseline scenario, and you can observe that the rail will about grow by 43%, road will grow by about 55%, and inland waterway by about 19%. So we are talking about an increasing freight transport market in Europe, and so it is obvious that we need new solutions, we need innovations to handle this this increase. And so we will do, our target is the comparison of high capacity transport. We have selected this EMS1, EMS2, and the scenarios I have explained in the slide before, but I want to repeat that our scenario approach, is the last two ones, are the external costs. We will include external costs in our modeling, so to show what is the impact if external costs will be included in the total cost of ownership. And further, we want to suggest a selection of some cargo groups, so to avoid that bulk transport and other transports that are not suitable for EMS1 and EMS2 will be shifted from rail to our EMS1, EMS2 in our modeling. That's we have to distinguish between reality and our modeling. But I can explain it later a little bit. Go on, please. So here you can see what we have done. These are the first thing we have to arrange with our project partners in the project. Our modeling works with different parameters, and we adjust these parameters together with the partners. And I want to give emphasis to the load factor, the cross combination weight, equipment and vehicle cost, and average fuel consumption. On the picture on the left-hand side, on the figure here, you see our approach that distinguish between EMS1 and EMS2 and shows us the increase of cross combination weight and the increase of costs. In our modeling, we distinguish between time-related costs and distance-related costs. And you see an increase in all these vehicles compared with a standard. But I have to emphasize that this is a vehicle-related observation. It is not for the transport itself, not from the company level or from the logistics level. But this is the input we have to generate for our modeling, that we have at first an increase of gross combination weight and an increase of costs compared EMS1, EMS2 with the standard. On the right-hand side, I want to point out that this is the assumption we have agreed with Ton and Hilal about what does mean to use CargoCam and puzzle software. And we selected some commodity groups, and on the right-hand side you see our assumption how the average load factor due to this puzzle software, this double stack and CargoCam could be increased in average. I have to point out that we only work in modeling with average numbers. We are not able to make really transports, but we have in our parameters we can build up a methodology so that we can have these average numbers of increase of efficiency. Next slide. So this is the scenario Ben has mentioned yet. We want to figure out what does it mean if external costs will be included in transport costs. And you see there's a difference between the modes of about 2.4 cents. That is road more expensive for this study. We use a study of Infras as a reference. And you can see the different colors here. And Ben has mentioned that the blue one and the green one are the relevant at the moment. Noise is especially relevant for rail, but also a little bit for road. And on the left-hand side, in the third bullet point, I have, because it is maybe it's the question that I have indicated which pre and post related processes are meant in this green color. And so I would summarize that these are indirect costs that comes from these post and pre-related processes of transport. And I have mentioned here this in a little bit more in detail than the other costs. Next slides. So, and the last scenario, I say we want to select or exclude some cargo groups in our modeling, and these are on the right-hand side, you see the cargo groups we want to avoid to be transported by EMS1, EMS2. And that's possible in our model because we are modeling every cargo group for in a several step of modeling. So we are able to say some cargo groups are not allowed. And this is our suggestion. This scenario is work in progress. So we have not fixed it yet, and we have not gained the first results. And as I said at the beginning, our general objective is to avoid bulk, to avoid very heavy, to avoid waste, and to avoid also something like the removal products from households and so on. So now I want to hand over to my colleague Christoph from MAN. He will explain something about the use cases we have started in the beginning of the project, but now we are working on it to show the impact also. Christoph.
Yes, thank you, Andreas. Hello, everyone. I'm Christoph Jasperger from MAN Truck and Bus. So here you see the results of 2 use cases. In total, 30 use cases have been derived from interviews with different logistics service providers, fleet managers and shippers. And these use cases show typical logistic chains of road, rail or waterways. And they help us to filter out the potential efficiency gains of prime candidates in everyday transportation operations as a substitute for current vehicles. So on the left, use case 1, here you see a CO2 emission reduction potential of roughly 26%. This is based on a trip from the Netherlands on road to Germany, then on waterways to Finland, and back via water to Germany, and back on road to the Netherlands. And here you see on fleet level, the saving factor 2 to 1 comes from substituting 2 trucks and 2 semi-trailers with only 1 truck with 2 semi-trailers and a dolly, this EMS2 setting. On the right-hand side, use case 2, here you see a CO2 emission reduction potential of roughly 32%. And this is based on a single mode logistic train from Austria to Germany on the road. And here, this is the EMS1 example with a fleet level saving factor 4 to 3. And this comes from a more complex recombining rigid trailer combinations and truck semi-trailer combinations to this, what you see here in the picture, the rigid dolly semi-trailer combination. Yeah, thanks. So let's get back to Andreas with a summary and Q&A session.
Yeah, thank you, Christoph. Yes, I want to summarize our part here now with some benefits and recommendations we have found yet, but we have to do more for this thing in the last few weeks. First of all, the benefit, yes, we think there is an impact on CO2 emission of road freight transport, and we want to find out how we can quantify this. And we hope that there will be a decrease in road mileage due to use of EMS1 and EMS2, and so we also can limit the reversal mode shift from rail and intermodal. We have C, and this I want, I'm not shown, but we see the lower average transport costs due to higher efficiency of EMS1, EMS2, and the shown cargo cam and puzzle software and double stack loading. We see here, as this was Christopher said, a big impact on the company logistics level that is dependent from trip and route planning, but that we also that could not be derived on this macroscopic modeling as full, but we have done this by our average assumptions. the impact of using EMS1 and EMS2 in combined transport is work in progress at the moment. We are calculating reduced costs for pre and post haulage, but we can consider first that these reductions are not so significant that they compensate other effects. Further, our recommendations, yes, we think that we should be focused on good classes with high ton kilometers and expected growing of transport volume. We should give emphasis to logistics optimization to increase load factors with focus on EMS1, EMS2, for instance, in hub and spoke concepts. And last but not least, the ramp up of EMS1 and EMS2 should be aligned with intermodal transport concepts, so that the benefit is yeah, in the whole EU transport, freight transport area. Thank you for this. This hand over to Ben to the questions, or should I do?
Thank you, Christoph, and thank you, Andreas. Fernando, if you could take over for the Slido, then we can go through the Slido questions. And in the meantime, in parallel, I saw that there are many questions also in the chat box. Anna-Marie, I hope you have noted all these questions, because we want to come back to these questions either during this meeting or we will come back to the people themselves. The first Slido question you see is, do you have variations of EMS2 and EMS1 with conventional configurations? How is the handling of such extra trailers for trucks when you have to take a highway that goes through the mountains? Those are the questions from the chat box I see. Do you have comparisons of AMS with conventional configurations? Christoph, maybe for you, I think yes, we have. Huh? Hello, Christoph.
Yes, you're right.
I think we have to dive in then the typical use cases we have. As you said, we have 31 use cases. So we have made an overview of 31 use cases, and there we indeed have made some comparisons between EMS and EMS2 and with the conventional configurations. So we certainly will include that in our reporting of this project. The second question, how have you checked with carriers and operators potential use cases of the cargo cam? Hilal, what is the situation on that? Hilal?
Yes, I'm here.
Okay. The question about the carriers and operators for potential use case for the cargo cam, I think the first one is now Procter & Gamble test. Do we have other tests in planning?
Currently, our focus is Procter & Gamble tests only.
Okay, but everybody can get in contact with you to get on the list of interest, I guess.
Yes, definitely. Yeah.
Okay. Tom, question for yours. Is the double stack trailer only possible in box configuration, or is it also possible with certain standards?
Yeah, the flexible floor as we developed in this trailer is only in the box configuration possible. But we can make a double stock floor in a curtain sider that's on the market, but then you have more places per floor. Okay. So we can divide it in 3 and then we can make it curtain sided.
Okay, thank you. The next question is about would it make sense to do the modeling per cargo category and even segment in each category? Andreas.
Yes, it's difficult to explain our cargo modeling approach in such a circle and in short time. As I said, we are able to distinguish between cargo groups in our modeling. We modeling step by step every cargo group. we have to be aligned with the European commodity groups that are this 20 by so-called MSTR groups. And yes, and segments, the segments are difficult. We can not really modelize the segments I have shown in my slide, which say we only use pelletized goods or we only use parcels. And modeling in segments we could not do. That's a problem, yes.
Okay, certainly something to dive in. How to regulate, motivate investment and keep track of schedule and enforce. Difficult question. I think we will come back to that when we talk about access policies and our idea how we will approach this topic. Did you compare these use cases with using the combined transport of a part? Christoph, are there use cases where we also have to deal with combined transport? I guess yes.
Yes, you're right. We need you to have a closer look to the different use cases.
Okay.
But you're right. Yes, we can show that in the deliverable.
The ones who have said anonymous, maybe people can make them name aware that we can also come back to the people to answer. Okay, Fernando, can we go to this?
Yeah, in most cases we're in the chat and I included, so then normally we should go on that.
Okay, thank you. Then this was a result of the aerodynamic features. Can we go to the next questions about the EMS vehicles? So the question is, EMS 1 and 2 vehicle configurations, which one has the highest potential to become relevant in transport and logistics? You can choose either EMS 1 or EMS 2. So EMS 1, we have two configurations. It is the tractor with semi-trailer and trailer. The EMS 1 is then, the other one is the rigid with the trailer, or EMS 2 is of course the tractor unit with the double trailer. And you see a very clear answer for the EMS 2 vehicles. Can we go to the next question, Fernando? We keep this open, I think that we can have the answers also later. Select cargo groups to prioritize for EMS. Andreas has explained what kind of groups we would like to exclude or to add. So in this, you see the cargo groups which we were intending to exclude. The question to the audience is do you agree that we exclude them, or do you want to that we add one of those here still in our EMS validation? So that means if you say, yes, I really want to have that, for example, number 14 is included, or number 17 or other, then you can identify this. I understand this is difficult to answer in that. Okay, thank you. There's some answers coming. Fernando, can you go to the next question and leave that open so that people can still keep on answering the questions?
The only issue is that people can only answer one by one. So.
Okay, good. Then I wait for 1 minute. Then let me get some answers. Okay, then let's go to the next one, Fernando. This was the last question, I believe, in this section. Are the present scenarios and use cases addressing those with higher impact of EMS 1 and 2 on European freight transit? Yes, I agree. Or no, I recommend. So here you are invited to use the chat box to give your feedback when it is about, do you have some disagreements with those scenarios? I see there are 10 answers saying, yes, I agree. But be invited to come back to us because we are really hoping on some critical feedback here, because you have already imagined that it is a very difficult subject to really simulate things and make from that a projection in the future. There is one question for Paul Brandt. He is not sure whether he understands the question right. Andreas, maybe you can give some comment to this question.
Yes, of course. The background of this question was we are now work in progress in modeling, and so we have defined the scenario I presented to you. So, and as I said, there's a critical point with the reshifting of cargo from rail and inland waterway to road due to improved performance on road. This is an inside situation in modeling that the modeling is cost driven, and if I reduce costs, if I have higher efficiency, I will see that the model shift will change. And this is a problem in the communication to the politicians. And that's why it was our question, if you have further ideas, how we can, in our scenario approach, find solutions to show that the shift to EMS1 and EMS2 will benefit the whole transport area or freight transport area in Europe. This was the general idea.
All right, he understood. So I think we have clarified the situation. Good. To continue looking at the time, I would like to invite Julius to continue with the subject e-dolly and next steps. I think also a very interesting subject. Julius, please continue.
Yeah, hello everybody from my side. I'm happy to present the latest development on the powertrain working package. Right now I'm in the AEROFLEX truck on our test track at MAN Munich. At the moment we're doing last tests before the truck goes to IDIADA for the fuel consumption tests. What are we doing? The core idea of our working package is to design a distributed powertrain. That means we do not only have a torque source in the truck, but also in the trailers. When we started this project, we focused on a hybrid concept, so meaning a combustion engine in the truck and electric motors in the trailers. But of course, the whole concept is easily extendable to battery, electric, or fuel cell vehicles. We designed a global energy management system in the truck, which coordinates the powertrains in the truck and the trailers. The vehicle units communicate via a new communication protocol. This is, I mean, by now there are several projects and concepts with electric trailers, but as far as I know, we're still the first project who really have a deep integration of the electric powertrains in the truck powertrain control. That means we have a really we can apply a good strategy of in propulsion and also in braking. So we fully integrated the electric motors in the brake control of the truck for endurance, so we can recuperate endurance brake energy and service brake energy. Moreover, as the most important hardware development in the project was the smart power dolly or e-dolly, which you see in the picture right on the right side below. That's a 250 kilowatt electric axle and an 80 kilowatt hour battery. We, of course, can operate it within the train, but also separately via a remote control. Next slide, please. Why a distributed powertrain? What are the advantages? We can reduce fuel consumption and emissions. In the current prototype, we have a pure hybrid concept without plug-in, but it's also, of course, extendable for a plug-in concept. So the idea is always save fuel. We have a very good improved in traction and driving stability. That means we could, for example, operate also an EMS2 vehicle with an only 4x2 truck, because we have more driven axles in the trailers. And of course, the core idea is to allow a flexible combination of the intrinsically efficient vehicle units. The global energy management system, as said before, provides an efficient operation of the units together. And what you see in the video on the right side, on the upper right side, the dolly can be used for maneuvering the trailers on a yard. And on the lower right side, you see a nice video of the remote controlled dolly in operation. Next slide, please. So what's our status? We truck, dolly, and trailer. All units are ready. We did a large commissioning program at the ZF test track in Jeversen. Maybe one aspect I did not mention before, ZF also provided a new communication technology based on automotive Ethernet. So that's not directly visible from the outside, but an important difference from the inside. And on the right, in the right video, you can see our powertrain display, which shows how the vehicles operate. So we have you can directly see how the dolly and the trailer, how they support the truck in propulsion and in recuperation. You see the state of charge of the batteries. Yeah, so that's how it looks like for the driver. All functions are working. We face hopefully smaller problems, which we tackle here in Munich, and then the combination goes down to Idiada, to Spain. Next slide, please. Some slides to for the e-dolly. That's actually the topic of Henning from the Fraunhofer EV. He cannot be here today, so I do my best to speak for him. The smart power dolly allows splitting of the vehicle in self-driving units for manual shunting of trailers in terminal yards. That's a very important aspect, which will really help handling of large combinations. The dolly enables EMS1 and EMS2 combination. We have an electric drivetrain enabling use of a standard truck. So that means 4x2, even if we go up to EMS2 and 74 tons. The dolly can be remote controlled, but of course the idea is in a later stage to control it in an autonomous way. And in the future, the dolly can be used also in combinations with battery electric or fuel cell driven trucks. That's of course possible, and also I think the direction in which we are all moving. Some other aspects: safe handling of vehicle and single units, reduce energy consumption, reduce numbers of drivers, reduce vehicle kilometers per ton of freight, and reduce costs of operation. What are the next steps? Now that we have a first prototype, which is really well working, the idea is to found a new consortium, which has the goal of driving knowledge and the further development of the dolly, and finally bring it into a market. We have a lot to do in analysis of cost benefits. We have to really collect the use cases to find the sweet spots where a dolly in the first hand can have a market penetration. Yeah, so that's basically what lies in front of us, and yeah, I think we can go to the next slide, yeah, where I want to point out the questions which we really would like to get answered by you, which gives us an idea of how you feel about the topic. So for the distributed powertrain, which obstacles do you see for integrating an e-trailer and e-dolly into logistic processes? A plug-in option in the trailer or dolly could further decrease fuel consumption. What do you see as a minimum amount of fuel saving in % to consider integrating an additional charging process into your logistic processes? To operate a double trailer combination with where normally a 6x4 tractor is necessary, an e-trailer or dolly would allow to operate such a combination with a 4x2 tractor. How high could the extra cost for such a feature be? So you would consider buying it. So that's very concrete as a question. An e-dolly will allow maneuver trailers and terminals in the first step with a remote control and future automated. How high could the extra cost for such a feature be? So you would consider buying it. And finally, do you see any other advantages of using an e-trailer or an e-dolly where maybe we did not think about yet?
Thank you very much.
Yeah, thank you.
Julius, I think a very interesting topic here. I have added also the weight proportions of a self-driving dolly and a normal tractor unit. So, because that was one of the questions from our last webinar, where we were asked what is the weight of a self-driving dolly. Of course, it depends on the size of the battery. We have built a very heavy dolly. Julius, how much weight is how big is the battery in the dolly?
It's 80 kilowatt hours, so it's already quite a big battery. Yeah. It could be larger, and of course, it could be much smaller. Yeah, it depends on the driving strategy.
Yeah. So a remark from Stan Wandel. Thank you very much, Stan. The cost reduction anywhere. Oh, that goes quick. Improves the whole system, and relative prices are allowed to change. It may lead to induced traffic and modal shift. It's political unacceptable. However, policy intervention can prevent that, and that's exactly what we are going to do with the topic of access policies, which we will come back in a few moments. Then we have a remark from Mark Bildet for the e-dolly. The weight could be challenging. Weight allowance would be required in order not to have a negative impact. EU rules could allow currently 1 to 2 ton. Yeah, as I said, Mark, we have built a very heavy dolly with a very big battery. But you can, of course, do much lighter batteries with much lighter capacities. We have really focused on a dolly which can also drive over a longer distance, which is not necessarily in many cases. Do you think the design is also possible for low deck? Yes, the design is possible for low decks. We have looked at this being a design also for mega trailers. So Bart, I think a positive answer for your cases. And that is indeed what Julius is claiming, that we need to address a lot more use cases to see, do we have the right design and how have we defined this specification finally to bring this dolly to the market. And I think we all agree that we want to have this dolly on the road. Then Fernando expressed to Stan, indeed, it is the point that opening up some avenues may support achieving some policies. Yes, we really want to use the benefits in line with the Green Deal to really drive the topics forward. Then we have Mr. Lati Otto. In Finland, we allow 3 different EMS, and ever use can choose. Yes, of course. We only showed here some EMS1 and EMS2 configurations. We have identified 27 vehicle configurations over the EMS1 and EMS2. I believe you saw this picture of also earlier in our presentation. And depending on the use case, indeed, all operators are using, of course, the best configuration for them. And in the last part of this meeting, we are diving into these access policies and regulations, because we are looking how can we make this compliant to the regulatory framework in Europe. Okay, thank you, Julius. I allow one remark out of the group. Maybe somebody wants to add a remark before we continue. We have still some minutes. So one remark out of the group, please. Silence means that everybody is so far satisfied. Then I propose we continue with our last topic, intelligent access policies, and next step. Marta Toba and Elisa, you are invited to explain and to guide us through the last topic. Marta, please go ahead.
Thank you, Ben. Good afternoon to everyone. Well, as we presented in previous ALICE webinars, Work Package 7 is in charge of creating the book of recommendations in order to include all the technologies and all the results that you have seen during this presentation. The main goals of this work package is to establish a sounding board with a lot of members in order to advise and help us to create these recommendations. I take the opportunity to invite you to join our sounding board. When we started, we were only 36 people, and the family is growing, and we are more than 70 now. So if you want to keep updated on the work that we are doing, please write me or Ben, and we will add you to the mailing list. The second goal and objective of this work package was to draft the recommendations in order to review the standards and the legislative framework, so as we could include all the technologies developed in the different work packages. And the third objective was that these recommendations had to be delivered to the policymakers and the authorities in order to standardize and legislate the framework in order to have a multimodal use of the vehicle concepts that we were developing. What we have done over the last more or less 6 months, could you please go to the next slide? Yeah, we have been working on the book of recommendations. We decided to divide the book of recommendations in 2 working lines. The first one, as I explained, is the one that will include all the recommendations for policymakers, authorities, industries regarding the standardization and the legislation of the vehicle concepts developed during the project. And the second part is the one focused on intelligent access policies. So far, we have interviewed 35 people. We have done 4 quizzes with more than 19 participants. And last week, we did our 2 last workshops, not the last ones, but the last activity that we did was these 2 workshops, also with 15 participants from the different stakeholders clusters that we explained in the previous ALICE webinar, and my colleague Elisa will also further develop in a few slides. From the vehicle point of view, the latest updates that we have seen during these months are 2. I will talk about the tenders. The first one, which is bodies and trailers, development of CO2 emissions determination procedure, is a tender which is led by IDIADA, and it intends to develop the tool or update the tool Vecto in order to include bodies and trailers. This is something really, really related to our project, and we understand that the European Commission has already realized that apart from the standard vehicles, we also have to consider different bodies and trailers. On the other side, there is another tender also launched by the European Commission, which is further developments of Vecto and update with new technologies. So far, we have explained a lot of developments and technologies developed in the AEROFLEX project. So this tender also includes the technologies that we have been working on, so also very related to the project. And last but not least, from the regulation point of view, my colleague Uriol, which is the expert today from the homologation department, will provide some insights on the latest news on regulations.
Yeah, the latest update. Okay, yeah. Thank you, Marta. Good afternoon to everyone. So firstly, I'm going to introduce an important European legislation that we are taking into account for the creation of the Book of Recommendations. It is the Directive 2015/719 that applies amendments to the original masses and dimension regulation. This amendment introduces new maximum authorized dimensions in national and both in international traffic, and maximum weights in international traffic. Okay, so the directive defines that derogation on the maximum length is needed in Europe in order to allow to the manufacturers the fitment of aerodynamic devices, but also the development of the elongated cabs. And additionally, the directive also defines that for these vehicles that are fitted with alternative powertrains, the extra weight given by these systems should not be counted as part of the effective load of the vehicle, since this would penalize some way the road transport and the deployment of these systems. All these changes have been implemented through the new regulation on masses and dimensions that was issued in 2019, but there is still more room to introduce the technologies that we are proposing in this project, as you can see. So currently the Commission is working with new amendments on the regulation and also for the vehicle combinations regarding international transport. This is intended for 2022 or 2023. So our main objective is to provide useful recommendations to the Commission that are aligned with our findings of the project. The recommendations will be mainly focused on modular combinations and new powertrain systems, let's say, because the aerodynamic devices and elongated cabs are somehow already taken into account in the last regulation on masses and dimensions. And now our colleague Elisa is going to provide the last updates on intelligent access policies that will be included in our Book of Recommendations.
Thank you, Oriol.
Yes, thank you very much, and good afternoon, everyone. Yes, so yeah, the key to implementing the sustainable and efficient vehicle concept as developed in AEROFLEX is developing intelligent access policies. And here on this map, you can see the widely scattered number of access policies that are currently in Europe. And you can imagine that this is quite a burden for introducing new vehicle concepts and also for smooth and seamless international transport. So therefore, intelligent access policies can be an opportunity to take away these burdens by managing access. That doesn't mean like putting EMS1 and EMS2 everywhere on the road, but having the right truck on the right cargo on the right time, at the right cost, on the right road. And by having this IRP, we can regain the control on the logistics and transport operations. And in this IRP task force, a group of experts is joining to develop this pathway towards intelligent access policies. So if you go to the next slide, and then what does this IRP entail? Well, it involves a match between the vehicle characteristics and infrastructure characteristics. And for this, vehicle performance envelopes are established that reflect the vehicle characteristics such as size, weight, or maneuverability. And also for infrastructure, this can be done such as characteristics like maximum load or road capacity. And real-time data sharing, you see the vehicle to vehicle or the vehicle to infrastructure communication and the meter traffic regulations, and through real-time data sharing, we can establish a match. For example, when areas are already congested, which will be reflected in the infrastructure level, then we will not send extra vehicles there. And very important to mention is that IAP should be based on allowing rather than restricting access. So there should be high-level harmonized rules and standardization, but there should also be room to manage local circumstances, such as local congested areas or specific infrastructure characteristics, without causing too much scattered policies. And this balancing act needs a group of experts to agree on the technical and on the technical requirements, so that EMS vehicles can be used for cross-border freight transport. So what are we currently working on in AEROFLEX? Marta already introduced it. We are working in this iterative process where we started with interviewing experts and then putting all those experts together in various quiz meetings in February, where we had interactive discussions on how to move this forward. And last week, we worked further on this through various IAP workshops. So, so far the highlights are that actually all stakeholders agree on the positive view on EMS vehicles. These are really considered to be game changers with respect to efficiency and sustainability. And also, it is acknowledged that IAP is needed to realize this potential. So, and this should start at experimenting at the local level while at the same time collaborating on the EU level. And also, it is highly advised in this group to use this momentum and pick up the interest of DG Move. So if we go to the next slide, we see some highlights or things that were discussed during the quiz meetings. So first of all, we discussed, what should we actually do to get these sustainable and efficient vehicles on the road in Europe? And well, one of the things that was mentioned very often was harmonizing these policies, and also that a shared vision is needed. And I will come back to that later. We worked on that in the workshop meetings. So in this IAP, also some challenges are recognized. And first of all, that there might be a resistance to change with various stakeholders, and also a resistance to share data. Because for establishing this match between vehicle characteristics and infrastructure characteristics, we need to share data, maybe vehicle data or transport data, data on infrastructure, which might be quite challenging at first for example, transporters or road authorities. So we need to take that into account. But also success factors were determined, especially when linking IAP to the Green Deal. This can really drive this change. And also, if there's trust among the parties and if concepts of data sharing are scalable, the experts expect that success will be realized. And closely linked to the Green Deal comment, a highly cited opportunity is the acknowledgement that the EMS configurations can contribute to the reduction of road freight emissions, and that we really should use this as an important enabler for this. So when going to the next slide, how are we creating this common story? Well, last week we had a few workshops on this, and we are building a vision in iterative steps. By having collaborative discussions, taking into account all stakeholder groups. You see them on the bottom left, the users, the policymakers, the planners and owners, the providers and facilitators, by also taking into account a community perspective. The community is really important stakeholder in this sense. And by community, I mean the general public, so that could be you and me. And we came up with several personas to make this a bit more tangible. So in these workshops, we discussed what would be the concerns of other road users, such as cyclists or assertive drivers, of people that might be a little bit scary or not so fond of driving. How would they react to to these type of EMS vehicles on the road. So that is all we try to take into account to determine the next steps for IAP. And also we link this to local pilots that are currently under development, such as, for example, the pilot in the Netherlands, which you see on the bottom right corner of this slide. Yeah, so what we did in this workshop, we worked on a newspaper, that could be published in 2030, claiming that IAP is a success and claiming what we have achieved by implementing it. So we started by brainstorming on a title that would grasp attention. And you see here on this slide, it is still under development, so it's not set in stone yet. But you can see that the discussion went from really explaining what IAP is, like the right truck on the right road at the right time, from appealing to people's emotions, like what can it get to us? Well, it can get transport in a green and groovy way. Then when opening a newspaper, on the middle pages, we took a closer look at the various stakeholder groups as mentioned. And here the themes that I already discussed earlier came back, such as trust and transparency, that is important, that IAP can contribute to a more robust and sustainable system. And also very important in these discussions was the role of the facilitator, a neutral organization that can connect all stakeholders and that can really drive this change. And also we discussed what should be the next steps, or what were the core achievements that made IAP a success. And you see a list here, which is still not finished. We are working on that. But yeah, the first step is creating awareness. So that's kind of the phase we're in now. And we are working towards getting all stakeholders involved, looking for an organization that can really drive this change, and also see whether small scale showcases on a regional or national or bilateral level can be established in order to show the benefits of IAP. So what's next? Well, these workshops are done now, but we will continue working on this by next workshop in May or June, as Ben announced already earlier, and we will further make the next steps more concrete, and we'll think on how to secure budget and how to bring this in the IAP agenda. So I think now in the slide, a question for you will appear. Do you want to join the IAP task force as an active person? Do you want to actively think along and help develop this common story? Or do you want to contribute to this IAP task force as an advising expert? Yeah, we are really happy to get in touch with you. So I'm looking forward to receiving your reactions.
Thank you very much, Lisa, also Martin, Oriol. Yeah, to all the people who are listening, please get in touch with us to get to know yourself, whether you want to support us to contribute in this activity. We believe that access policies can really bring this topic further, and that it really can help improving the transport, high capacity transport and high capacity vehicles on the European roads. Looking at the time, I would like to continue because at 4 o'clock, our time is gone, and I see that some people are leaving already. So if you allow me, I would like to continue, and with the closure part, to give us some minutes to tell us about Outlook and what is coming next. Looking at our project, you have seen a lot of innovations, and you have also seen that we still have a lot to do to meet the targets in 2030 and beyond. So also what Julius explained, that we are setting up a consortium to what is next with the e-dolly to bring this vehicle to the market. So we are looking to organize scaling projects to further demonstrate and implement the new technologies and systems. We want to link EMS vehicles to zero tailpipe vehicles, and we are looking to a project for a holistic approach. For that, we are very happy and we are very proud that we are working on a project proposal in line with the Horizon Europe, and that is the modular multi-powertrain zero-emission system for heavy-duty vehicles for efficient and economic operation. It is our intention to indeed use our AEROFLEX demonstrator, and as Julius already indicated, yes, there is now a diesel motor fitted, but of course we can either build in a battery electric drivetrain or a fuel cell drivetrain, because the AEMPT technology is independent from the driving source. So this could be part of this project, and you as LS member or logistics operator, you're really invited to join us in setting up this consortium, because we want to include LS members, we want to include logistic operators, further logistic service providers, shippers, because we need to better understand the needs and the requirements. We need to further develop the vehicle concept, but also the charging infrastructures. We need to show and demonstrate the cross-border applications so that we really can build a bridge between regional, local, national, and EU circumstances. And as said already, we really want to build in these emission-free tailpipe drivetrains included with the e-dolly and e-trailer, first of all, to achieve these zero emission driving, and secondly, to reduce energy consumption overall, and to improve the vehicle drivability, as Julius also presented in his part. And this is more or less the concept of our project. We are looking at how to integrate all the stakeholders, how to integrate use cases which do cross-border activity, really using electric charging, hydrogen fueling over long distance regional applications, really to have a good mixture of two use cases covering regional, national, and cross-border. And I think I was very happy reading that the LS Hydrogen Corporation, because that is a sign that with our proposal to go on with this project proposal, like I just presented, we are on the right way, and we should use this momentum to drive it forward. So you are kindly invited to support us, and you are kindly invited to come back to us. And what I really want to see is, and Fernando, maybe you can put on the Slido now that we can see what are the first reactions of our audience with regard to what workshop they would like to join as a follow-up workshop. There it is. In the meantime, I also still have a question to answer from Marcel Otto. Are you aware of the standardization request for the EC on OBW? And yes, we are. We are also wanting to incorporate it in our vehicles. So, and of course, we will do that, Marcel, and we will also come back to you to discuss further details. Thank you. I see the first answer is that, okay, only one person has answered so far. There are the coming 9 persons. So it is very clear that the dolly and the access policies have already created some enthusiasm. Now also other are coming as interest. I'm very pleased to read this. What is for sure is that we will definitely hold these 6 workshops, and because we need those workshops, because we need to know your argumentations, we need to know your feedback to sharpen our end report at the end of the project, as said, end of September. I see that all the Slidos will be available as well. So thank you very much for this feedback. You can come back to us via the chat box as well. Fernando, I take now over again. So if you have questions regarding these workshops, you see here my mail address. Please come back to me and I will ensure that you will be part of this workshops and that you will get on time the invitations to join. Further, I want to stress the point of the Physical Internet Conference, 14 to 16 June. We will be there again, the AEROFLEX project, because we think we want to do there at least 2 sessions. So 2 of the 6 workshops planned will be during the IPEC 2020-21. And finally, I would like to draw your attention to our outlook. Save the date already for our final event, the 28th of September this year. It will be a full-day hybrid event. That means, depending the COVID situation, we will allow a certain number of people to be present. And we have a very interactive program. On this turning circle, you have a full demonstration of our EMS 1 and 2 vehicles. On the loading ramp, you will see a full demonstration of the double stack trailer with the cargo cam, the puzzle software. And in the customer area, you will have a full demonstration of all the other work packages as we have shown. And during the lunch break, you can drive on the oval with our demonstrators, not yourself, but you can be in the cab and you can see all it working. Before closing, I would like to ask Fernando to have a closing word. Fernando.
Just to say thank you, Van, and the whole team of AEROFLEX for, again, an excellent webinar and session with a lot of progress since last time. And looking forward to meet you all virtually in IPEC in June and hopefully face-to-face in Germany in September.
Thank you very much, Fernando. At the bottom, you see the link to the AEROFLEX project website, on which you will see every time the latest update of our final event. As said, come back to me. And yeah, I would like to thank the audience for this 2 hours listening to us. I hope it was very interesting. And yeah, see you soon back. The speakers, can you stay on board so that we can make a